So this session is related to acid-base equilibrium MCQs, multiple choice question. We'll do question related to the topic. As in the last session, we completed the topic. So first we'll do the multiple choice and later we will do the structure questions. Question number 1. The dissociation of a methanoic acid in aqueous solution is endothermic. So when methanoic acid dissociate, methanoic acid is HCOH. So as it dissociate, it will dissociate into H plus and COO, HCO negative ion. When a sample of aqueous methanoic acid is warmed, so the reaction is endothermic. Endothermic reaction, if we increase the temperature, equilibrium will shift towards the right hand side. So as the equilibrium will shift towards the right hand side, what will happen to amount of hydrogen ion? The amount of hydrogen ion will increase, and we know pH is equals to minus log of hydrogen ion. So if amount of hydrogen ion increase, the pH of the solution will decrease. So what will be the right answer? A will be the right answer. Why not B? Because pH does not change, that's wrong. Why it is wrong? As the amount, the concentration of hydrogen ion changes, the pH will also change. Then the concentration of undissociated HCOH will increase. So the concentration of undissociated HCO will not increase, it will decrease. As the forward reaction is endothermic, it will favor the right hand side. The concentration of methanoate ion decrease. The concentration of methanoate ion will not decrease, it will increase. Is it clear?
Yes, sir.
The next question, which solution has the highest pH? First thing, because when we have strong base, both sodium hydroxide and aqueous ammonia are base, but aqueous ammonia is a weak base, whereas sodium hydroxide is a strong base. And the pH and hydroxide ion concentration are directly proportional. If we increase the hydrogen ion concentration, the pH will
So B.
increase. So B is the right answer, because strong alkalis ionize completely. As they ionize completely, the amount of OH ion will be more, and you can see the solution B is having a higher concentration. That's why it will have the highest pH. Then an indicator which is having a range of 3.8 to 5.8 is suitable for titration. So indicator for a range of 3.8 to 5.8, like this is a vertical portion. So when we check the vertical portions, I will show you that part of the vertical portion, that so that you will understand that how to select the type of indicator. You have to learn that range. For titration curves. So these are the titration curves. So if we are using a strong acid and strong base, the vertical is from 3 to 9. Okay, that's strong acid, strong base. But if you are using a weak acid and strong base, the vertical is from 7 to 9, the vertical part. If you are using strong acid and weak base, the vertical portion is from 4 to 7. And so 1 is, if you are using strong acid and weak base, 4 to 7. If you are using strong base, weak acid, then it will be 7 to 9. So if you remember the question, the order which they provide here. So this is nitric acid. Nitric acid is a strong acid. And this is a weak base. So strong acid and weak base, what will be the vertical portion? Just now we discussed. So it will be from 4 to 7. So vertical portion is from 4 to 7. When we check ethanoic acid, it is a weak acid and strong base or alkali. The vertical portion is from 7 to 9, where the indicator ethanoic acid, and there is no vertical portion. Sodium thiosulfate and iodine, there is no acid base reaction. This is like a redox reaction but not an acid base. So we are left with option A or B. So we have the indicator which can show a color change from 3 to 5.4. So if the indicator can show a color from 3 to 5.4, this is a range of the indicator.
So A?
So in that case, nitric acid and ammonia. Is it clear? So A is the right answer. Is it clear?
Yes, sir.
Then different titration curves are there. The titration curves, the titration is carried out for aqueous solution with concentration 1 mole per dm³. So the curves are shown. Which curve obtained when hydrochloric acid and aqueous ammonia? So hydrochloric acid is a strong acid and aqueous ammonia is a weak base. So strong acid, so it will vertical portion is from 4 to 7. So which graph having a vertical portion from 4 to 7 when we check the options? 4 to 7 around, because it's a strong acid and weak base. So weak base, when we check the vertical portion, first thing, because it's a weak base, so weak base can have a pH around 12. And strong acid, so strong acid will have a pH around 1 or 2. So it means this either this, if the starting point is 1, the final point should be 12. If the starting point is 12, the final point should be 1. So why B cannot be an answer? B is starting around 2 but ending at 14, so that's why it is wrong. Again, C is wrong because starting from 14, so C is actually for strong acid and strong base. And when we check D, the option D, when we are checking, so it is starting from pH 0. So practically, we don't have a solution with pH 0. Theoretically, yes, there is a solution of pH 0. Practically, you don't have a solution of pH 0, so it will not start from 0. So you have only two options left, either A will be there or D. And see this vertical, so why this is not the right, because it shows starting from 0, while pH 1 or 2 is acceptable. So A is the correct answer when we are reacting hydrochloric acid with a weak base or aqueous ammonia. Is it clear?
Yes, sir.
So A is weak base, strong acid. This is when acid is there, weak acid, strong base. This is when strong acid, strong base, and this is when strong acid and weak base. But practically, like, it cannot start with 0, it should start with certain value of the pH. Then
And
which,
it says that HCl is added, so like it should be
yeah, other way
like
around.
first alkaline and then acid.
Yeah, that's right. For which titration would methyl orange not be suitable? So methyl orange, we have to check the vertical, like using a data booklet, we have to check the methyl orange range. The data booklet is here. This will be given in exam, the data booklet. During this exam, they will give you this, and once you finish, they will take this back. Indicator. What was the page number? Normally they specify the page 19. So page 19. Data booklet page 14. So this is the data booklet, page 19. We have methyl orange. Yeah, methyl orange is there. So methyl orange showing a color change. This is methyl yellow, methyl orange is there. The range is from 3.2 to 4.2. That's the range in which it shows a color change. So when we select a titration, the vertical portion should be from 3.2 to 4.2. So when we check, this will 3.2 to 4.2 will be here. If would methyl orange, like for which titration would the methyl orange not be suitable? So for this titration, it will be suitable because it is lying 3.2 to 4.2, it is in a vertical region. But for this titration, 3.2 to 4.2, that is not in a range, like not in the vertical part. Here also 3.2 to 4.2, or here also, like even one of the value is out, but the small proportion is in as well. So that is on also in a vertical. But for B, the change when the indicator is showing a color change, that does not lie in the vertical region, and even like minimum and the maximum does not lie in the vertical region. That's why for B it will not be suitable. Is it clear?
Yes, sir.
Next question 5. The reaction between concentrated nitric acid and concentrated sulfuric acid is shown. The Lorry-Bronsted acids are proton donors, bases are proton acceptors. So HNO3 become H2NO3. It means it accepts proton. So we call that as a base. And H2SO4 turn into HSO4. What we call that as acid, because acids are proton donor. So according to the Bronsted-Lowry acid, in this equilibria. So which one is the acid? They're asking about the acid. So when we check the forward reaction, H2SO4 is acting like an acid. And for reverse reaction, when we check the reverse reaction, so first it is H2NO3 turned into HNO3. So it means it is donating proton, and acids are proton donors. So for reverse reaction, H2NO3 is acid. For the forward reaction, H2SO4 is an acid. So the option H2NO3 is acting like an acid and H2SO4 are acting like an acid. That's why D is the right answer. Is it clear? Because acids are proton donors and the bases are proton acceptors. In question 6, the pH of 3 solutions with a concentration 1 mole. So ammonium chloride is there, ammonia is there, and ammonium chloride, sodium ethanoate is there, and ammonia solution. We have to work out the pH of the solution in increasing pH. So increasing pH, if we have ammonium chloride, First, this NH3 is a weak base, and weak base will have, like when we say the order, salt can be acidic salt, like salt can make a solution acidic, salt can make solution alkaline, or salts can make a solution neutral, but it cannot be in same order as a weak base. So we have NH3 is a weak base, and sodium hydroxide is not given. Now these are the salts, sodium ethanoate and ammonium chloride are the salt, but we have to check the nature of these salts. So the solution 1 will have the highest pH. This will have the highest pH, even though it's a weak base, but because others are the salt, so the weak base will always have a higher pH than salt solutions. So the first one, like the solution which will have the highest, and we need an increasing order, so means it will end at 1. Now ammonium chloride will dissociate into ammonium ion and chloride ion. And this ammonium ion, what is the tendency of this ammonium ion? It can donate proton, it can give out proton, because extra proton is there, so it can donate protons. If it can donate proton, it means the amount of the hydrogen ion in the solution will increase. So this salt solution will be acidic salt solution. So ammonium chloride will be acidic salt solution. And what about CH3CONa? This CH3CONa, when it will dissociate into CH3COO minus and Na plus. And then this CH3COO plus H2O, like water molecules are there. So it will accept proton from the water. So when it will accept proton from the water, CH3CO, and it will result in a formation of OH ion. So amount of OH ion increase in the solution because of this molecule. So it will be alkaline salt. So we have to write in order from like increasing order. So from lower
So
pH to
3, 2, 1.
3 to 1. That's why B will be the right answer. So basically the salts which are formed by weak acid, they make the solution alkaline. The salts which are formed by strong acid, they make the the salt which are formed by weak base, they will make a solution acidic. Question 7, a buffer solution is there. A buffer solution means a solution which resists a change in pH when acid or alkali is added. So there is a buffer solution is 0.1 mole per dm³ with respect to ethanoic acid and 0.05 mole per dm³ with respect to sodium ethanoate. The dissociation constant of ethanoic acid is given. What is the pH of the buffer solution? How to get the pH? First, the dissociation constant of acid. Like if you have CH3COOH, it will dissociate into CH3COO plus H plus. So when we write the dissociation constant Ka, it's product divided by reactant. So CH3CO, this is salt, the concentration of salt, concentration of hydrogen, and the concentration of acid. This, because this CH3CO is how much salt is there, that will be the same as concentration of. So if we need hydrogen, because to get the pH, first we should know the hydrogen ion concentration. So you can remember, like I can write Ka is equals to concentration of the salt, concentration of hydrogen ion divided by concentration of acid. And if we need hydrogen ion, so hydrogen ion concentration will be Ka multiplied by concentration of acid divided by the concentration of the salt. So we have Ka, concentration of acid and salt. If we multiply, we'll get the hydrogen ions. So, and then pH is equals to minus log of hydrogen ion concentration. So first we'll substitute these values to get the hydrogen ion. So hydrogen ion concentration is always the Ka multiplied by concentration of acid divided by salt. So Ka is 1.7 into 10 to the power minus 5 multiplied by concentration of the acid is 0.1 as they mentioned, and divided by concentration of salt, which is 0.05. This will give you hydrogen ion concentration, and after taking hydrogen ion concentration, you will find the pH using a formula. pH is equals to minus log of hydrogen ion. So you will get as 4.47. Is it clear? Then question 8. The equation for reaction between weak acid and sodium hydroxide is shown. The pH of a solution of a salt most likely to be. So weak acid and salt, whenever weak acid react with strong, because this is a weak acid and the salt is formed by reaction. So weak acid and strong base, so the salt which is formed will be alkaline. So which A and B cannot be an answer because A is showing that it is acidic, B is showing that it is a neutral. But neutral salt cannot be formed by reaction of acid with alkali, of weak acid and strong alkali. So these are the two alkaline. But as I mentioned that the salt solution cannot be same capability as like a weak acid, weak alkali or weak acid. So it will be less than that. So this 13 shows that it will be alkaline, but it shows it will be strong alkaline, the salt solution. But practically it's not possible, like they don't have too many hydroxide ions. So C is the right answer. So whenever you
And
mix
what if it was a strong acid and like a
strong
strong
acid,
base?
strong base, it will be neutral salt. And if
And
it is
weak base will be acidic.
weak base with strong acid, acidic. And if it's weak acid and weak base, that also a neutral salt.
So the weak one has the effect.
Strong one is having effect. Like example, weak acid, strong base. So the salt will be alkaline. If weak
Right. Okay.
acid, yeah, and if it is strong acid, weak base, the salt will be acidic. So the one which is stronger, that leads to the nature, that decide the nature of the salt form. In question 9, a very small amount of hydrochloric acid is added to a buffer. The change in pH is very small. What is the best explanation? How the buffer solution act, or why the solution does not change the pH when hydrogen ions are added? The
That would be
dissoci
D.
Yeah, the ratio, the concentration does not change because basically what happened, as we know, H plus is equals to dissociation constant of acid, then the concentration of acid divided by concentration of salt. So this factor, this ratio is not changing. The ratio of the concentration of acid to conjugate base or salt is not changing. That's why the pH won't change. The D is the right answer. Question 10. Which of the following solution when mixed would make a buffer with a pH greater than 7? So we want a buffer solution. First thing, a buffer solution, there are two ways buffer solution can be formed. It can be a weak acid and salt. So the buffer solution which will be formed will have pH less than 7. Or it can be a weak base plus salt. It will be a buffer solution will have a pH more than 7. So ethanoic acid and sodium ethanoate, it will be a buffer, but this buffer solution will have a pH less than 7. Sodium hydroxide and sodium chloride is not a buffer because buffer is only when weak acid and its salt or weak alkali or its salt. Ammonia with sodium chloride, that's also wrong because it's ammonia is there, but this is not the salt of ammonia. That it should have a salt of that same. Like if it's a ammonia, then it should be ammonium salt. So ammonia plus ammonium chloride, that will be a buffer solution, and that buffer solution will have a pH more than 7. So D will be the right answer. Question 11. In acid solution, methyl orange is red. When alkali is added, the solution turns yellow. Because the indicator, so what happened to indicator? Why the indicator show a color change here? Because indicators, as we discussed, indicators are always weak acids. All indicators are weak acid. So if we add acid to them and they dissociate into what? They dissociate into H plus and In minus. So if we add acid or proton, the equilibrium will shift toward the left hand side. We'll get more molecule. But if we add alkali, means we add OH. So OH will react with this H, and amount of H will decrease, so equilibrium will shift toward the right hand side. So if we add, as they mentioned, when alkali is added, means when OH is added. So when we add this OH, H will combine with OH. So amount will decrease, amount of hydrogen ion decrease, or equilibrium will shift towards the right hand side. So indicator will lose its proton and it form a positive ion or anion. Negative ion, sorry, not positive. Negative ion or anion. Is it clear?
Yes, sir.
So indicators are weak acids. That's why when we add an alkali, the loses they react with H, the OH of alkali, and amount of H decrease, so dissociation or forward reaction increases. An aqueous solution of ammonium chloride has a pH less than 7 because. So why ammonium chloride is having a lower pH? So when we have ammonium chloride, NH4Cl, this will dissociate into ammonium ion, NH4 ion, and then Cl minus ion. And this ammonium ion, it will lose proton. So this will be H plus and NH3. And what happen when it will lose proton? This will donate proton to water molecule. So water molecule will take that proton and it will turn into H3O plus charge. So the ammonium ion donate proton to water and give rise to oxonium ion. Oxonium ion is H3O. And how the existence of oxonium ion is proof? Because when we carry out electrolysis, if there was no oxonium ion, then the conduction or rate of conduction of the solution should be faster. But practically, because of the formation, because oxonium ion is formed, so the solution does not conduct electricity at a faster rate, as oxonium ion is having a greater mass, so it's not mobile, it cannot move quickly. Question 13. Which of the following indicator is the most suitable for titration of ethanoic acid and sodium hydroxide? So we have what? We have weak acid and we have strong base. So weak acid and strong base, what is a vertical region? It's very important. So it is from 7 to 9. That's a vertical region. So we want to select, like we will check the, using a data booklet, we'll check the range for each indicator and then we will compare with this value. So this is question 13. So what were the indicator? One is thymol blue acid. Thymol blue. Is thymol blue? Yeah, thymol blue acid. 1.2 to 2.8. So it is 1.2 to 2.8. So it's not suitable because there should be overlapping, like the vertical portion where the reaction occur and the indicator, one of the values should overlap. Both are over there in the range, that is suitable, but one of the values should overlap. Bromo thymol blue, when we check for bromothymol blue, bromothymol blue, that's 6 to 7.6. So it is from 6 to 7.6. When we check thymol blue base, thymol blue acid is there, and thymol blue base 8 to 9.6. 8 to 9.6. And alizarin yellow R, that is 10.1 to 13. So 10.1 to 13. So now check, because weak acid have 7 to 9. So which one it matches? It cannot be thymol blue. It can be, because one of the values is lying. It can be bromo thymol blue. It can be thymol blue base 8 to 9.6, and it cannot be alizarin yellow, because it not does not lie in the range. So now, which is the best, most suitable? Most suitable is the one in which it lie on the vertical, like within the vertical region. So vertical region is from 7 to 9. So the indicator which is having this range from 7 to 9, that is C. Is it clear? Because from 8, like greater part is there within the,
Yes, sir.
like, because from 8 it will be from 8 to 9, and then from 9 to 9.6, because here like 8 to 9.6 this was there, so only this is 0.6 differ from the value. And when you check this one, it is from 6 to 7.6, only 0.6 is in the value, and this is about 1 is there in the range, this is only 0.6 is there within the range. So that's why we select for C. Then what is the conjugate base of HCO3? Conjugate bases are proton acceptor, like the substance which will react accept proton from this. So if we have HCO3, the conjugate base of the acid. So this is acid. So what are acids? Acids are proton donor. So if we donate proton, what we are left with? We are left with CO. Because if this thing is acid, then acid is a proton. They're asking conjugate base of the acid. So this is acid. And acid are proton donors. So this is acid. Then this is a conjugate base. It will accept proton to form this acid back again. So B is the right answer. Then what is the approximate pH of a buffered solution containing 0.2 moles of weak acid and 0.2 moles of sodium salt, and the total volume of the solution is 1? So concentration will be same as the moles. Practically we substitute the concentration, but because the volume is 1, so it won't make difference to the concentration. So concentration of acid, first we'll find the hydrogen ion concentration, and it's a buffered solution by weak acid and it's salt. So when we check, A cannot be an answer. We are left with B, C, and D. So hydrogen ion concentration will be dissociation constant, and that is the concentration of acid divided by concentration of the salt. K is given. Now in this question they give pK. We can find the K because it's like taking anti-log. Or there's also a formula which can relate the pH with pK. You can learn that formula, or you can take anti-log if you know the pK. So pK
So
is
10 to the power minus
4.8.
K.
Yeah, 10 to the power minus pK, because we need K, because pK is equals to minus log of K. If we need K, then it will be 10 to the power minus pK is equals to K. you can use that. You have the concentrations. So first find the hydrogen ion concentration. Or there's also another formula that if I take anti-log both sides, if I take log both sides, so this will be log of hydrogen ion. This will be log of Ka, and because in when multiplied in logarithm we add them, so this will be log of acid divided by salt. Then we multiply whole equation by negative, so it will be minus log of hydrogen ion minus log of Ka and minus log of acid divided by salt. So, and minus log of hydrogen ion is pH, so pH is equals to pK minus log of acid concentration divided by salt concentration. So you can use this formula as well, which is convenient to use. So minus log of acid divided by salt, pK is there, which is 4.8, minus log of acid is how much? Concentration containing 0.2 of weak acid. So 0.2 divided by 0.2. So that is 1. So log 1, that is 0. And because both have the same value, 0.2 divided by 0.2, so it's 1. Log 1 is 0, 4.8 minus 0. So we'll get as 4.8. Is it clear? Question 15.
Yes, sir.
So it's up to you. Like you can do the other way around. You can first find the hydrogen ion concentration and then use the value, or you can learn this formula as well. In question 16, when equimolar, like same concentration moles of two solutions are mixed, the buffer solution has a pH less than 7. So it means it's a weak acid and it's salt. So which one is a weak acid and it's salt? So ethanoic acid is a weak acid and it's salt. So this buffer solution will be B is the right. Hydrochloric acid, and that's wrong because strong acid does not form buffer. Sodium hydroxide and sodium chloride, that's also wrong. Ammonia and that will be buffer, but this buffer will have a pH more than 7. Question 17, the pH of 1.5 mole per dm cube hydrochloric acid is, so how to work out, we know first the concentration. Hydrochloric acid is a strong acid, so it will ionize completely. So the concentration of H will be same as concentration of HCl, and we'll use the formula pH is equals to minus log of hydrogen ion. So minus log of hydrogen ion, that is 1.5. So what's the answer? So pH is minus log of hydrogen ion. When you substitute this value, the minus log of 1.5. So 17, it will be minus 0.18, or B will be the right answer. The information about 4 samples are shown for acid. Which of the following lists a sample order of increasing pH? So when we check, like this is a strong acid, this is also a strong acid, this is also a strong acid, and this is a weak acid. So first thing, weak acid will have the higher pH. So what we are left with when we check, so 4 should have the highest pH. So either A will be answer or C will be answer. For question 18. Then even though HCl is a strong acid, but H2SO4, because H2SO4 it produces 2 protons when it dissolves as compared to HCl. So H2SO4 will have the lowest pH because it gives, like one molecule of H2SO4 give 2 proton, whereas one molecule of HCl give only 1 proton. So it will have the lowest pH as it is having a greater amount. So then the second it will start with 2. So starting with 2 and ending at 4, so C will be the right answer. So, and we can also work out like the sample 1 is a high concentration than sample 3. So if the concentration of acid is more, strong acid is more, its pH will be lower. So it will be 2, 1, 3, 4. Is it clear?
Yes, sir.
Then question 19, a solution of a weak acid cannot be titrated with weak base to find the endpoint. Because, so what is the reason for that? Why for a weak acid and weak base titration is not possible? Because the pH change is too gradually close to equivalence point. Like we don't have a vertical part, the pH just instantly changes near the equivalence point once the acid reacted with an alkali. That's why it is difficult to say, use an indicator. Like pH change is not a vertical, the pH change is too gradual close to the equivalence point. Like at equivalence point means when all of the acid is reacted with an alkali, and that is the moment the solution is changing a pH. So vertical portion is not there. That's why we are not able to use a specific indicator. And question 20. Ethanoic acid is mixed with water. What are the Bronston-Lowry conjugate acid-base pair? So if you want to work out the acid and the base pair, so CH3COH become CH3CO. So it is donating proton, it is acting like an acid. And conjugate base, so this will be base, conjugate base. And H2O is accepting protons, so H2O is acting like a base, and H3O positive is acting like an acid. So when we work out the pairs, because we need a pair, so if we say this is acid 1, so what is a pair of this? This is a conjugate base. So if this is acid 1, this will be base 1. So acid 1 and base 1. And if this is a base, right, because already we mentioned base 1. So if this is a base 2, then H3O will be acid 2. That's why C is the right answer. So conjugate, like what is the meaning of acid 1 and base 1? It means acid which is having a conjugate base. And what is the meaning of acid base 2 and acid 2? The base which is having acid, a conjugate acid. So these are questions related to topic, the multiple choice question. Next session we'll do the structure questions.